Muy buenos días. Soy Juan Alberto Alcántara y a nombre del Instituto Politécnico Nacional y el CIIEMAD, y en el marco de los festejos del 85 aniversario del Instituto Politécnico Nacional, es un gusto darles la más cordial bienvenida a esta sesión donde escucharemos la conferencia Geochemical Process and River Sediments of Malasia, Climate Change and Contamination. Procesos geoquímicos en sedimentos fluviales de Malasia, cambio climático y contaminación. Actividad que forma parte del programa de la Cátedra Patrimonial en Medio Ambiente Héctor Mayagoitia Domínguez 2021, en su 6ª edición. Presento a nuestro excelente ponente del día de hoy, que nos hace favor de acompañarnos. Me da mucho gusto darle la bienvenida al director del Instituto de Investigaciones de Curtin, Malasia, al doctor Ramasamy Nagarajan. Cabe mencionar en esta situación que el doctor en Malasia son las 12 de la noche. Sea usted bienvenido y muchas gracias por aceptar la invitación. You are welcome and thank you very much for accepting to invitation, doctor.
Thank you, Dr. John.
También le doy una cordial bienvenida a la maestra Shakti, alumna del CIIEMAD, para apoyarnos en la parte de traducción de las preguntas y respuestas.
Muchas gracias, doctor.
Bueno, vamos a decir la dinámica de esta sesión. Será la siguiente. El ponente tendrá 45 minutos para su exposición y posteriormente tendremos una sesión de preguntas y respuestas de 15 minutos.
Good morning, everyone. I kindly present our speaker who does the favor of joining us today. I'm very pleased to welcome Dr. Ramasamy Nagarajan, the Director of Research Institute in Curtin University, Malaysia. Welcome, Dr. Nagarajan, and thank you very much for accepting the invitation. The activities of the section will be, the speaker will have about 45 minutes for his presentation, and later we will have a question and answer session for 15 minutes. Thank you, doctor.
Les recordamos también que pueden hacer las preguntas por el chat de YouTube, que nos indiquen su nombre, la institución a la que pertenece. También les recordamos a los alumnos BEIFI y a las personas interesadas que puedan solicitar su constancia de asistencia de acuerdo con los parámetros que se encontrarán en la página del evento. Bueno, antes de pasarle el micrófono a nuestro excelente ponente del día de hoy, me permito compartirles un breve resumen de su semblanza. El doctor Ramasamy es licenciado en Geología por la Universidad MS en el año de 1997, maestro en Geología por la Universidad de Madras en el 99, también el doctorado en Geoquímica en la Universidad de Anna de la India en el año de 2003. El doctor ha sido decano en la Universidad de Malasia. También el doctor Ramasamy, sus principales líneas de investigación son las siguientes: geoquímica, sedimentaria y ambiental inorgánica y orgánica. También el doctor Ramasamy ha tenido premios como el mejor trabajo a la investigación en el año 2008 y en el 2011. Y finalmente, el doctor tiene más de 100 artículos publicados a nivel internacional.
Before we start this section, let us have a brief introduction about today's presenter. Dr. Nagarajan Ramasamy has graduated in geology from MS University in 1997. He did his master's in geology from Madras University in 1999 and did his doctorate study in geochemistry from Anna University of India by 2003. Dr. Nagarajan has been worked as Dean in University of Malaysia, and his mainstream of research is inorganic and organic sedimentary and environmental geochemistry. Dr. Nagarajan has been awarded as the best research work in 2018 and 2011. Also, he has more than 100 articles published in the Index Journal by international level. It's a great pleasure to have you today, sir. Thank you very much.
Doctor, ¿puede iniciar la presentación? Doctor, you can start with the presentation. Thank you, Doctor.
Can I start sharing?
Yes, please.
Okay. So, very good morning, everyone. So, ladies and gentlemen, it's my great pleasure to connect you all today through IPN. So, I would like to thank IPN for giving me this opportunity to share my decadal research I conducted with my team in Curtin, Malaysia, and also collaborating with IPN Mexico and UNAM, Mexico. So today, I'm going to summarize some of different research part is combined together and see the connectivity between the source to sink relationship and the impact of climate change and contamination in part of the world, the third largest Borneo island. So today, my presentation going to be in this structure. So an introduction to Borneo, and then study area, activities, geology and geochemistry, some findings from the different part of research, and then the effect or impact due to climate change in the coastal regions, as well as the coral reefs of the South China Sea and a part of Borneo Island, and also some of the action plan taken by the government to mitigate and also to have a sustainable future in Borneo Island. Okay, let's start with the Borneo. So when we talk about Borneo, so it's one of the hidden island between Pacific Ocean and South China Sea and Indian Ocean. So Borneo is not a country. So your island is shared by the 3 countries, Malaysia, 2 states, and Indonesia and Brunei. So Indonesia covers 2/3 of the island in the territory, and then Brunei is the smallest. Malaysia has 2 states in Borneo Island, namely Sarawak and Sabah. In terms of size, it's really big. So world's 3rd largest, and also in compared to the size, it's a double the size of Germany. So it is a home for 18 million people with 200 ethnic groups, in which about 50 ethnic groups from Sarawak state alone. So this Borneo has one of the famous mountain called Mount Kinabalu, which is off of Mount Everest. And this is the tallest mountain in Southeast Asia. Again, Borneo has another indigenous and unique character. So Borneo is really old because it consists of about 140 million years old rainforest, and one of the oldest forests in the earth. So Borneo Island is really wild and consists of a lot of wildlife. So far, the researchers might have explored only 50%, in which they have identified just about 15,000 plant species, in which 400 species were identified recently, the 19th century and 20th century. So it is a home of many mammals and animals, and also some of the famous animals called orangutan, rhinos, pygmy elephant, clouded leopards, and poboscis monkeys. These are the famous animals in Borneo Island. And some of the animals, around 44 out of 200 mammals, are endemic because this is only can be seen in Borneo. So also Borneo Island naturally fighting against climate change by accumulating carbon in its forest. So the rainforest is continuously accumulating carbon or sequestration carbon over 140 million years. So whenever we disturb the nature, of course, the effect will be as a result of the change. So the result can be seen visibly on the downstream side. So the forest destruction, which has led to decline the bird species, mammals population, as well as lost a lot of indigenous medicinal plants, and also other species. So the subsequent consequences of the forest degradation or forest destruction, which can be seen now in the South China Sea, in the coastal shelf region. So where we have a coral reef ecosystem, and also it's affecting the regional climatic patterns. So let's see how the Borneo look like. So as I mentioned, Borneo is really unique in terms of culture, in terms of some of the species is unique in Borneo alone. So with this background, I'd like to introduce the study area I'm going to cover today is the northern part of Borneo Island. I'm going to cover about 2 rivers. One river is called Baram River, which is really come from the typical rainforest. It's the second largest river in Sarawak state. And another minor river is urban river, it's called Miri River. And both empties in South China Sea. So within the 20 kilometer of distance between the 2 mouths. So if you talk about Asian rivers, so which are the major contributors of sediments to the ocean? So the most of the flux sediments come from Asian rivers, particularly the tropical climate, which favors physical as well as chemical weathering, and subsequently bring a lot of suspended matter as well as sediments to the ocean system. So by studying the aquatic system in tropical conditions as well as the sediments, we can predict the climatic change, the climatic impact, and also the relationship between the source and sink. In particular, when we use inorganic geochemistry from the sediments and water, either combined or individual, which provides a lot of information about the processes takes place during the journey or from start to the end. So in particular, the knowledge on the tropical rivers are still is not to the level. It still need to explore more. So the present study is also contributing, filling the gaps, some gaps. It's not really fulfilling all the research gaps. It's trying to solve some of the research problem in this region. So in this photo, you are seeing the downstream of the Baram River with the turbid effect into the South China Sea. So towards the right-hand side of the mouth, it's moving towards Brunei. Towards the left is moving towards Malaysian part. Okay, so today's my presentation covers 3 parts. One is the Baram River, the river highlighted with bright color. Second, shown in yellow color, is a Miri River basin. The third, the line shown in white, there is a Miri beach. Then adjacent to the Miri beach, we have a coral reef. The coral reef of Borneo Island also unique. So what is the unique? It is a turbid coral, can survive under high turbidity. We'll see what is the type of coral and what is the effect. So if you see more clear here, so I take the downstream part of the Baram River, the Miri city with the Miri River basin. So the coral reefs indicated as Anemone's garden and Eve's garden. So these two coral reefs are really surviving at the shallow depth as well as under turbid water. Okay. So when I talk about Baram River, the location called as Marudi. So this was the ancient river mouth, is about 5,000 years ago. So over 5,000 years BP, so the progression of the river towards the ocean has developed this estuarine system. So now it's river system. Previously, the estuarine system was migrating from Marudi towards the present river mouth location called Kolabara. So Curtin has invested is about 5 million together with the Sarawak Energy, is a company, local company, governmental company, to study the effect of Baram River into the natural ecosystem on the South China Sea. So far, we have completed nearly 10 projects and another 6 projects are still ongoing. It's about monitoring coral health as well as to study their colony and also the future potential of development of such coral species as artificial coral reef in this region. So as I mentioned, Baram River and Miri River are the main concentration of the study. These are some of the key points about the river system. So Borneo is the second largest river in Sarawak with a catchment area of 22,800 kilometers square. So Borneo receives rainfall is between 2,500 and 4,000 millimeter, is a typical tropical climate. And this variation, the 2,500 to 4,000, is between upstream and downstream. In particular, the Miri city receives about, as an average, about 2,700 millimeter per year. So this Baram River delivers about 50 billion meter cube of fresh water and 24 million tons of sediments annually to the South China Sea. So during 1960s, the Malaysian timber was one of the famous timber in the world. And Indonesia and Malaysia were contributing about 50% of the world hard timber from the tropical forest. So with that economic potential, many licenses were given during 1970s. So the effect of the deforestation and the poor action after that, it had the effect on the downstream side, particularly on the downstream lower Baram, as well as the coastal region of South China Sea. But still, the Sarawak state is having about 63% of the land covered by primary forest, and the remaining area is secondary forest and other land uses. So when we have more deforestation and subsequently have more sedimentation in the downstream side. So the Miri River is very small. It has about 582 square kilometer catchment area. So the upstream region is mostly peat swampy land, is now used as a palm plantation area, which also confluences to South China Sea at the middle of the Miri city. So these are some of the activities. You can see how pristine the water is in the upstream side of the Baram River. Then you can see some of the deforestation activities. So the typical, even man cannot go, there is no road facilities where timber extraction going on. So the timber roads, the temporary roads, you could see. So this as the negative effect after the deforestation or timber extraction is over. So that makes the river turbid throughout the year. If you look at the downstream side of the river, the lower Baram River, some port activities, industries, dredging, as well as sand mining. So the river sand is a main fine aggregates in the construction area. So sand mining is common from Baram River. So while Miri River has different scenario. So Miri River have the upstream mostly covered by palm plantation. Whereas in the downstream side, mostly shipping and harbor activities. So due to that, you have oil spill on the river water. Then squatter colony houses is a timber houses is just constructed over the river. And then urban development on the peat soil, which explores and dig and put aside the peat soil. So now it's exposure to the atmosphere. And then some mangroves, as well as this is the river mouth. So the both rivers have a different unique characters. So since Borneo have a lot of water resources, the state government come up with many dam proposals. So in which 3 proposals currently in operation is called Bakun, Murum, and Patang. Whereas another 10 projects or 11 projects were proposed, but unfortunately by the protested from the locals. So all the dam projects have been stopped for a while. So currently other studies have been undertaken in order to see the sustainability, whether is can be explored further or not. So in this study, many methods were used. So what I'm going to summarize is a mixture of the different methodology. Basically, the sediments were collected from 2 different seasons for Baram River, upper and lower bar. For Miri River, only monsoon season, and coastal part, both monsoon and post-monsoon season. So we did bulk geochemistry for 2 fractions. One is the homogeneous bulk fraction is about less than 2 millimeter in size. Another one is fine fraction is less than 63 micron size. Bulk mineralogy, humus scan mineralogy, petrography for the river sediments were carried out. In addition, grain size analysis was carried out using sieve as well as laser particle size analysis. And then zircon geochronology for determining the age of the zircon heavy mineral, and the remote sensing and GIS to study the morphometric changes of shoreline as well as the river mouth changes. Then carbon dating on the core sediments collected from the lower Baram River, and then sequential extraction and analysis was carried out by using 2 different methods. One is the Tertiary protocol, 1979. Another one is PCR protocol. And then statistical analysis are used in order to interpret the huge data sets. Okay, the geology. The Borneo have a unique characters in which particularly in Baram River Basin is mostly covered by the deep water turbidites belongs to Oligocene to Eocene in age. It is called Rajang group. So this deep water turbidite, it's showing alternate sequence of sand and mud sequences and partly metamorphosed, and majority of the deposits are low-grade metamorphism. That's why it's called meta sediments of Rajang group. So after the Rajang group, there is a big unconformity. So the Miocene sediments basically derived from this Rajang group of sediments. So since Miocene until today, this provenance is more or less same, but it's all getting recycled. So since majority of the area consists of sedimentary rock or metasedimentary rock, and the tropical climate, which favors for more erosion and more weathering. So at the same time, the deforestation and the land use changes in the Baram catchment area, which brings a lot of sediment to the South China Sea or the downstream. The Miri River Basin mainly consists of Neogene sediments, particularly Middle Miocene to Pliocene in age sediments. So this is also mostly sedimentary rock, sandstone, and shale with some limestone lenses. So which also have some Pleistocene terrace, which is also recycled sediments, and recent alluvium in the coastal bed and the downstream side also. So let me go through the geochemical results of these river sediments. So I'm not going to explain in detail about all the parameters we studied. The uniqueness of all the 3 ecosystems. First of all, if you compare major oxide on the left-hand side is a Baram bulk and post-monsoon and monsoon season. So overall, major oxides, calcium and sodium, are highly depleted against UCC. So it's showing it's a mobility nature. Calcium and sodium have the higher mobility compared to other oxides, and subsequently the silica is enriched in all the samples. If we take trace elements, particularly chalcophile elements, in particular, if you want to say arsenic, copper, zinc, silver, and some other chalcophile mineral elements like tin, tungsten are showing enrichment in the upper as well as lower Baram River basin. If you take Baram River, Miri River, which is a bit different from Baram River, which shows wider variation. In particular, the blue represent upstream sediments, the red represent downstream sediments. The downstream sediments are enriched with many metals, so which is showing the mobility of element between the upstream and downstream. So here also the another uniqueness in terms of trace elements, the chalcophile elements showing enrichment compared to UCC. So what about the beach? The coastal region of northern Borneo, which is also comparable to the Baram River system in terms of major oxide, as well as the trace elements. So since it's a beach where sorting is common, so some of the heavy minerals might show the enrichment, particularly zircon and hafnium, sometimes chromium, which are a bit enriched than UCC. However, the uniqueness is the chalcophile elements are enriched, in particular arsenic, copper, zinc are enriched in the beach sediments. Okay. How the weathering intensity in this region? So basically, when we have a tropical climate, it is expected to have more intensive weathering. But in reality, it's not. As I mentioned before, since Miocene, these sediments are recycled. So during Oligocene time, the primary sediments might be derived from different parts of the island, and also other than the island, the source region were liquidated. So now they are under the sea. It's called Sunda Land. It is below the South China Sea now. Okay. So when they go for second cycle of sediments, already it should have it should show the geochemical nature as intensive. But in reality, the current river sediments showing moderate weathering. So their range is almost the same in all the river as well as beach, is between 60 to 80. So in terms of average, 68 or 72 or 74, which indicates moderate weathering. So why? When we have a recycling, it's a multiple cycling, should have more weathering intensity, but in reality, it's not. Why? This is the unique characters of Baram River sediments. Particularly, the sand particles are not the really minerals, quartz or feldspar. The sand particles really have broken fragments. It's a lithic fragments of the source rock. So basically, the source rock influences the chemistry. In addition, grain size affects the overall chemistry. So when we talk about mineralogy, so of course, a different variety of mineralogy. But I would like to highlight, in particular, among us, the clay mineral, illite is the dominant compared to kaolinite. So that is the unique feature. So when we have a tropical weathering, we are expecting, so kaolinite content may be higher, but in reality, it's not, illite. At the same time, you can see there's humuscan images. It's all the minerals are together. That is a lithic fragment. So one lithic fragment consists of quartz, albite, goethite, zircon. Is a one grain. So what you interpret from chemistry, so what you see in mineralogy sometimes is not matching. For example, clay minerals is considered, should be associated with fine fraction. For example, Al2O3 rubidium, K2O, should be mostly associated with the clay mineral. But when you look at the grain size, these clay mineral based elements are associated with sand. So that is a uniqueness, because these sand particles, these lithic fragments, is made up of mudstone on which you have multiple grains. So that's why that differences. Another uniqueness I will be discussing later in terms of chemistry. So you can see the thin section images. So quartz have two varieties. One is the sedimentary quartz from the source region. Another one is metamorphic quartz from the veins developed during the metamorphism. And you can see the variety of lithic fragments. So they are occupy mostly sand fraction. Whereas in the fine fraction, the real minerals, quartz, zircon, all the heavy minerals, they occupy in the fine fraction. Okay, when we talk about provenance, so what is the source of these sediments? Basically, as I mentioned, Rajang group is the source for all Baram River, as well as Miri River, as well as the beach sediments. However, the Rajang group of sediments are the catchment area. Also, I have some volcanic rock. So, which is highlighted here, the mafic igneous provenance here in the first two diagram. Whereas when you see on the lower Baram River, almost the mafic minerals almost gone weathering. It's showing only the recycled characters. So, which is also common in the Miri beach. So, Miri River showing different characters is because of the enrichment of iron and also diagenetic effect on the Miri and surrounding formations. So, in order to conclude, we used different method, different ratios, different discriminant plots for finding the provenance. So let me summarize very quick way. So this is the summary for Baram, not only Baram, in the northern Borneo region, all the sediments from Oligocene to recent. So the major contributor are like this. So these areas were identified based on the youngest peak of edged peaks from the zircon cluster. The oldest cluster is separated, whereas youngest cluster classified into three. So one is the dominant cluster is between 117 to 130, with the dominant peak between 114 and 119, which represent lower Cretaceous. So the lower Cretaceous provenance is expected. The Swanar Mountain granitites is located in southern part of Borneo. In Indonesian part, it's called Kalimantan. And also the Swanar Mountain is consisting of metamorphic group. So these were the primary source within Borneo. So another edge group, which has about 220 to 240, so which is suspected to have two different locations. One is Sunda Self, currently below the South China Sea. Another one is the West Malaysia, is a Malay-Thai tin belts. So these tin-bearing granites, which is not unique within Borneo Island. So it should be either derived from Sunda Self, or it's also including Malay-Thai tin belt granites. And then the oldest zircon in the range of Meso to Paleoproterozoic in age is 1,300 to 2,440, which is mainly derived from Indo-Australian plate. The youngest edge cluster we identified from the Baram River Basin is 4.5 million years. So which is the youngest volcanic rock. This is the one of the primary rocks in the northern Borneo. Is a felsic to mafic volcanic rocks. It's called Usanapau. So these are the major four sources which contributed to the Borneo. The first three, the main contributor for the source region of these rivers. The last one is the contributor for Rajang as well as the current beach sediments. Let us discuss about the environmental significance. So this natural system. So what is the uniqueness? Is there any enrichment, or is the sediments contaminated due to human interferences or natural geological processes. So the enrichment of any metals is no need to connect always with the interference with a human being. This natural process also can enrich certain elements in the riverine system, estuarine, as well as coastal systems. So just now we saw the normalized plots, multi-elemental plot against UCC, upper continental crust. The same you can see here. It's multiple environmental factors or indices were used, such as contamination factor and geoaccumulation index, which two are summarized here. If you look at this, as I mentioned before, the chalcophyll element shows the variation, the major enrichment. The maximum values recorded are chalcophyll elements. Specifically, you can see copper, zinc, and arsenic in upper and lower Baram River, as well as if you go to Miri River, the same copper, arsenic, antimony. If you go to the beach, copper, lead, and zinc. Okay. So if these elements are enriched in these sediments, which might affect the aquatic organisms in this region. So the contamination factor is a straightforward. Normalizing against the background values will show if there is a contamination. So in order to nullify the effect, the geoaccumulation index are used. So the geoaccumulation will remove the effect from the provenance and then show the reality in terms of enrichment or contamination. If you look at again, so arsenic, copper, zinc, which are common elements showing enrichment, particularly the upstream, the arsenic and copper are higher, whereas in the downstream, mostly copper, zinc, and other mineral like tin. Whereas in Miri River, mostly arsenic, antimony, and copper. If you come to beach, it clearly shows that copper and zinc are really enriched during monsoon, whereas during post-monsoon, even some samples recorded lead content. Okay. So if this enrichment of these elements going to affect the aquatic organisms or not. The effect of element in the aquatic system, it will be depend on the mobility of the elements. So let's see. So what will be the effect based on the existing method is called Long et al. By comparing the background values. So when these values exceeds the ERM, effective range median, so it is expected to have some effect on the aquatic organisms. So the summary is that in the upper Baram River, during monsoon season, the only nickel is having above ERM value. So nickel may affect the aquatic organism in the upstream. Whereas in the downstream, you can see copper during monsoon season, which is showing above ERL. Whereas in the Miri River, so none of the elements are above ERL, so no problem. But ERL to ERM range may have some effect in the near future, but its a potentiality is only 50% compared to above ERM values. Okay, now you see the scenario totally different in Miri Beach. So Miri Beach, both seasons are showing highest concentration of copper. So the copper is highly enriched. So due to copper, there will be some impact on aquatic organisms. So is it really going to have impact by copper in aquatic organisms? So we had a study by studying fish, shrimp, bivalves, and crabs in this region. We found that the high bioaccumulation by three metals, which is copper, zinc, and manganese. So this is the trace metal content from fish in this region. Fish is some of the migrating animal, so it is not representing one particular area's contamination. So this is representing a regional phenomenon. However, this bioaccumulation pattern is unique. Zinc and copper and followed by manganese. So that means, are these elements are highly mobile and these are bioavailable? So we have to see whether it's really bioavailable. So zinc and copper is more necessary, is a nutrients for human body as well as animal. But however, when it's accumulated above a certain level, is considered danger, some toxic effects. So then crab also showing the similar pattern like fish. So now we have to see fish is a water feeding organisms, whereas crab is a sediment feeding organisms. If sediment is contaminated with copper, zinc, manganese, then crabs should show the highest accumulation. But fish also showing accumulation, that means which is showing the seasonal variation between the river and coastal ecosystem. Or sometimes the riverine or estuarine system is maintained in the coastal region because of the tropical condition. So the beach water is something like similar to the estuarine condition, which have the uniqueness of the estuarine condition. So the accumulation pattern also similar to the fish. So the same were observed in shrimp. And then we also studied some foraminifera. We found some of the foraminifera chamber have been deformed due to the pollution, particularly the coloring. The decoloration and turning to brown is due to the effect of copper. So which was recorded in foraminifera, but not in astrocarps. So now we wanted to check the mobility or bioavailability using two methods called sequential extraction by using Tessier protocol and BCR. So what is the difference between these two? The sequential extraction by Tessier, which shows the 5 different fractions, exchangeable, metals bound to carbonates, metal bound to FeMn oxides, metal bound to organic matter, and metal bonds in the crystal lattice of the mineral. So the first 2 phases are dangerous because the pH and EH variation in the aquatic system may release the trace metals to the system. Whereas the FeMn oxides depends on the EH condition or redox conditions, whereas the organic material is oxidizing at redox condition. So these FeMn oxides and the organic matter mostly act as scavengers or the carriers of metal in the system. The BCR test is combined, the first and 2, the rest are similar. The exchangeable and bound to carbonate fraction are considered as a BCR step 1. Then step 3 in BCR step 2. So likewise, it has only 4 steps. So BCR sequential extraction procedure was adapted for Miri River and beach sediments, whereas the Tessier protocol were utilized for upper and lower Baram River. Okay, so let me summarize. Upper Baram River and lower Baram River, which shows Mn mostly associated with the exchangeable fraction. So in the Baram River system, manganese are highly mobile and highly bioavailable. At the same time, copper is a second bioavailable. So most of the copper found in F4 fraction, that means associated with the organic matter, but also in the F2, in the carbonate fraction, and then exchangeable fraction. So the most common bioavailable element in the Baram River system is manganese. If you come to Miri River, Mn, zinc, as well as Pb. So now you could see there are 3 elements, particularly Pb in F2 fraction associated with the carbonate, whereas M1 and Zn is mostly associated with the exchangeable fraction, particularly in the lower Baram River or Miri River estuary. If you come to Miri Beach, there are 3 elements, copper and zinc, which is unique in both seasons. That Pb is common only in the northeast segment, which is mainly associated with the F1 fraction. So now we can think the bioaccumulation are the different organisms we studied, which reflects the mobility nature. So Zn, copper, and Mn are the first three metals accumulated in the aquatic animals. So because these elements are bioavailable in this region, so that is reflected in all the organisms in this region. So there is a connectivity. So as per the mobility calculation, so mobility calculation is very simple index. Combine the F1 and the F2 fraction of both method like Tessier protocol, F1 and F2. In BCR protocol, the first fraction against the total value will give you the percentage of mobility. So if we take Baram River, the M1 is showing about 40% are bioavailable. So the high accumulation or association of M1 in the first fraction may be risk to the aquatic animal, subsequently may affect the human beings. However, some effects is reported, the strong neurotoxicant at elevated exposure. But in the present scenario, the total M1 content is lesser than 1500 ppm in this whole system. So there won't be any immediate effect for the organisms by consumption of these fishes and these aquatic organisms. Okay, let's see the proxy, climatic proxy. So we did a core geochemistry, and we analyzed, which gave an age from carbon dating age from 1900 to 2800. Particularly around 2300, we had a reversal age. So we removed that one to calculate or normalize the age towards the depth. So when we calculate the average sedimentation rate, so it's about 0.15 centimeter per year. By considering variable sedimentation, so it's vary between 0.12 centimeter per year to 0.80 centimeter per year. So these trends of these elements, which clearly indicate, particularly, you see the silica content is keep on increasing, but suddenly start to decrease. Similarly, Al2O3 showing opposite trend. So this highlighted in the box, which shows the last 3 decades activities taking place in this region. So the enrichment of alumina, K2O, MgO, this all reflects enrichment of mud or silt. So this is a fine fraction, which is associated with the deforestation effect. So huge sedimentation, washing away the humus material. So after washing the humus material, so it's bringing all the slope material which were covered by the previous forest cover, but now is exposed to the atmosphere. So the major deforestation and land use changes, particularly conversion of forest into palm plantation. So in the first 3 years before the palm plantation stabilizing, the sediment loss will be more. So that gives more sediments into the Baram River system, subsequently delivered into the downstream as well as subsurface. So similarly, these are some of the trace elements showing similar trend, and particularly if you see copper and zinc is keep on decreasing. But more to be covered in this core sediments, so we are doing it currently. So land use change, which is unique due to the famous value for Borneo timber. So that's why it become hotspot for deforestation. So one is deforestation connected to the timber extraction. So second deforestation, second point is related to the land use changes. Particularly, the deforested land are rich in humus soil. So those soils are used as agricultural land for rubber as well as palm plantation. So the first 3 years, so 3 to 5 years will take to survive the young palm to become stable. So in that time, the soil erosion are a bit high. So one of the studies says in 1930s, 75% of Borneo was covered by the pristine tropical forest. But now only half of the original extent left. Particularly, the major loss is from the Kalimantan, Indonesia part, because Indonesia accounts 54% of the total palm oil production in the world. So, as I mentioned before, Sarawak still having 63% of land as a primary forest. On the other side, the adjacent country losing the primary forest because of oil palm plantation. So the extensive drainage, when we convert the degraded land or deforested land into palm oil, there will be ploughing of these materials, particularly in the downstream side of the Baram River. These areas mainly consist of peat soil. So when you test the peat soil, when you make a drainage for having a palm plantation, it is make more susceptible for the forest fire. So forest fire in this region is a unique phenomenon, particularly in the summer. So during the summer, the peat soil exposed to the atmosphere undergo for forest fire. So it is unpredictable as well as uncontrollable, which creates a major loss for the palm plantation owners, as well as the local small-scale farmers. In addition, it also leads to poor air quality in this region. So the SPM value sometimes quite danger for a week of time during the summer. So we used remote sensing GIS techniques to see is there any effect due to the deforestation. So we covered about nearly 15 years from 1991, about 23 years. And we see initially the Baram River do not have any barrier island until 2005. So the 2005, particularly between 2005 to 2009, the erosion is more, and which brings a lot of sediments to the mouth of the river and having a lot of accretion of sediments in front of the Baram River mouth, which form a barrier island. And subsequently, the wind direction and the longitudinal as well as these shore currents, which facilitated to form a tidal flood zone, which connects the mainland to the barrier island. Then after 2010, what happened? So this barrier island, particularly the sand pit developed, is gradually reducing, is disappeared. So which is related to less rainfall. So due to less rainfall, less sediment input, so which is diluting the sand pit form in this region. So if you look at the overall trend, the rainfall pattern as well as the land use changes, it is something like it's a decadal cycle. So every decadal cycle, it's the change is happening. So is there any relation between the climatic change versus this type of decadal variation? Let's see. So if you look at on the beach of Borneo, you could see the thick pile of organic matter. So these are the typical material derived from two places. One is the organic matter is a humus soil from the upstream region. The log also come from upstream region. The second, so the undecomposed peat soil from the downstream region. So upstream region, from the deforested land, all the humus soil is fine humus soil is washed away. And at the same time, in the downstream area from the palm plantation area, it's all the peat soil are washed and dumped in the beach. Sometimes when you walk in the beach, you feel that you are not walking on the sand, but instead you are walking on the foam bed. So below the beach, you will see have a 1 to 2 meter thick peat soil accumulated. So this peat soil accumulation is clearly indicating the effect of land use changes as well as deforestation in the upstream side. So here is the summary of the Baram River mouth and the Burial Island, how has been changed over the period of time. So the background value we take from the topography to 1974. So 1974 was the too broad opening, and then there was no burial island in front of this one. Whereas after 2005, the significant sediment input, particularly 1998 to 2008, maximum expansion between 2005 to 2010, which can be connected to the intensive deforestation, timber extraction in the upstream side, as well as the land use changes. We also explored the shoreline changes in that region. So we found that there is a variation, and particularly it is not only by the nature, also the human interference, particularly in front of the Miri River, as well as they construct a lot of jetties, which leads to sediment accretion in one place, sediment erosion on other places. So overall, when we compare, so the maximum erosion was between 1991 to 2001, is a 1 decade, whereas the maximum accretion was between 2001 to 2014. So this accretion mainly related to human interventions by constructing revertment gradients and also breakwater structure. So most of the Miri beaches now having breakwater structure to control the soil erosion and also to protect the natural cliffs and arches in the beach. So the total shoreline changes during the last 51 years shows more accretion than erosion. So more accretion means a lot of sediment supply. So the sediment supply, even though the river weathering, erosion, which are common factors, but due to land use changes in the upstream, which have aggravated the processes. So this sediment and turbidity in this region, indeed, it will affect the coral reef. So one of the study was conducted in the coral reef of Mirisibuti coral reef, so which is showing the lowest coral species diversity, and the health cover is about 22 to 39%. So if you see the coral disease, which is relatively low, even though they are surviving under turbidity. So bleaching was about 6.7%, bioerosion 6.6%, and scars 1.1, and mucus production is 0.5. So the bleaching was observed in 2016, however, is fully recovered in 2017. So it means that by having cyclic turbidity condition by this reef, which has a stability to sustain on this turbid coastal water, so which has a potential to use this species to extend in the entire zones of Sarawak, so where you see the highest turbidity. So this will be the future in this region to develop artificial coral reef using these particular species, which has a high potential to survive under high turbid condition, which is totally different from the coral colonies, which are sensitive to turbidity in the coastal zone. So which the typical coral requires a typical salinity, typical depth, and also less turbidity, but in this condition, which has a unique character. So in terms of climatic signals, the climatological study in Northern Borneo are limited. So we have three opportunities. One is core sediment core, another one is coral core as well as speleothems from the cave. But unfortunately, due to the poor precipitation of climatic signals, many studies were not carried out. The recent study by one of the collaborators with the Curtin group come up with a coral core and the climatic signals. So which clearly shows that there is an impact. Particularly, the O18 isotope of the seawater were reconstructed from the coral chemistry, as well as the strontium, calcium, trace metal measurement. So using these, the spatiotemporal dynamics were constructed and compared. So accordingly, the delta O18 of seawater displayed particularly highlighting the El Nino events in 1983, 98, and 2015 or 16. So which all indicating the drought conditions with the less runoff, high ocean salinity. However, El Ninos with the lower O18 values, with a shift of more saline condition between 1982 and 1995 to become less saline condition after 1995 due to high rainfall and more freshwater input. So which reflects the decadal shifts is found, which is mainly driven by Pacific decadal oscillation. And this is the first study bringing long-term data in terms of El Nino or El Nina, the southern oscillation, ENSO-driven synchrony of climatic impact for both terrestrial as well as land or terrestrial and marine systems in northern Borneo. And other studies we are also working out is from stalactites and stalagmites from the caves in that region. So more data to be developed for the climatic study. So which is clearly indicating that the sea surface temperature is rising, is about 0.26 degrees Celsius per decade since 1982. It's a clear indication that is the effect of climatic change. So what are the actions of the government which is related to Northern Sarawak and addressing these issues? Particularly the Sarawak government, the state government, developed a green plan. So this green plan to achieve the developed status of the state by 2030. So particularly, which includes developing a greenhouse gas inventory. So this inventory of greenhouse gas is not a common practice now. So particularly which has implemented now for all the economic sectors and cities, so that we know where to concentrate and what are the alternate plan for those sectors. In addition, the SDGs strategic plan is made compulsory for all the manufacturing sectors, including educational sectors, all universities. They are trying to adapt their sustainable policies and strategic plan, which is related to sustainable development goals set by United Nations. And then the government also putting more effort on forestry through aggressive industrial forest plantation. So they have a target, and the timber extracting industry and timber processing industry, they have to involve in this type of sustainable forestry exercise. They plan to have within 5 years to have a 5 million industrial plants. So this will bring out the secondary forest system, particularly in the degraded land or deforested land. And then artificial reef balls, which is started a long time ago, which is growing very good. So which is going to have an aggressive environmental protection. So upon continuation of this project for the entire coast of Sarawak is about 1,000 kilometer length, will have a complete artificial coral reef, which is the uniqueness of Sarawak in the future. So one of the oldest, one of the longest artificial coral reef, coral colonies in the world. So these are some of the aims. In addition, government, state governments putting a lot of effort by having integrated renewable energy projects and also microgridding systems to supply the power to the rural communities. It is not dependent on only hydro energy or thermal energy. This is a combined energy sector, particularly main grid connected to the microgrid with multiple systems. The huge investment on hydrogen energy going to have a solution for Sarawak in the near future, and also other potential such as tidal energy, geothermal energy, and other possibilities also looking into it. So these are going to give a future sustainability for this region. So Borneo, whatever explored is very, very less, more to explore. So if you are interested, of course, please visit Malaysia, particularly Borneo, and visit us to Curtin Malaysia. So if you wish to collaborate with Curtin Malaysia or Curtin Australia, so please contact our office, ord@curtin.edu.my. So with this note, I'd like to conclude here. So thank you so much. If you have any queries and questions, so you can ask now. Thank you.
Muchas gracias, doctor. Es muy interesante la presentación y le agradecemos. Y próximamente tengo muy seguro que vamos a estar participando con la Universidad de Curtin. Ahora, bueno, pues iniciamos la sesión de preguntas y respuestas. Vamos a ver, por aquí tenemos la primera pregunta a cargo del doctor Pedro, profesor del CIIEMAD. Querido doctor, ¿cuál es el objetivo de estudio del zirconio?
Doctor, the first question is from Dr. Pedro. He's a professor from CIIEMAD. His question is, what is the role of zircon in the study?
Role of zircon, basically to pinpoint the provenance for these sediments. Actually, the provenance, I said before, here in this region, all the sediments are recycled. So when it is recycled, to pinpoint the major provenance in this region was difficult. That is why zircon geochronology was adopted. So those statistical zircons were clustered into different groups. Then it was connected to the source rock exposed on that region, particularly during the depositional time. So that is the main purpose. The second purpose is for mineralogy and also to do the transportation history based on the roundness and sphericity of the zircon grains. So we compared whether the zircons are derived within Borneo or derived from some other than Borneo region. Because so far, particularly Jurassic age source rock, which is not common in Borneo, but we have some clusters of zircon. So zircon dating really giving a clear answer for us to address the provenance of sediments in this region. Thank you.
Thank you. Y vamos a la siguiente pregunta, doctor, de la doctora Alejandra Pérez, también profesora de aquí del CIIEMAD. ¿Cuál es el papel del gobierno para mitigar la deforestación?
Okay, the next question is, what is the role of government to mitigate the deforestation?
Role of government, okay. This is now the legal parts of the license given to the timber extraction. So particularly, of course, I mentioned the Borneo is shared by 3 countries. So the differences in legal actions and the strictness, which leads for illegal deforestation and illegal poaching in this region, particularly the Sarawak government, the northern part of Borneo, which is now it is well established rules and also very strict policies were maintained. Particularly timber extracting industries and timber processing industries should participate in the rapid aggressive industrial plantation. So this will help to recover the forest in the near future. So how much they deforested or extracted from the upper region, the equivalent area, they have to develop a forest in the near future. That is the agenda. So they are bringing back the reality of Borneo through industrial plantation rather than the uniqueness what it was in the real tropical rainforest. Yeah.
Thank you, doctor. The next question. Pregunta el doctor Jonathan, de aquí del CIEMAD. Dice, ¿cómo es el proceso en la isla frente al río Baram? Ahora, ¿se ha agrandado o se ha disminuido?
Dr. Shakti, you are muted, I think.
Shakti?
Sí, doctor. Perdón. The next question is from Dr. Jonathan. Do you have any monitoring program for deforestation activity as a part of effort from the government?
Yes, actually we did two major projects. So the first project is a geochemical character assessment in the entire Baram River Basin. The second is to study the land use changes over the 5 decades. And we also quantified the development of road and deforestation. So for one of the company in this region. So since the data is under confidential, so we could not share here. Yes, we have done those, and also we are keep on doing it. And also many studies available. So what was projected based on the deforestation rate, they have predicted until 2020. So by 2020, like 50% of Bornean forest is almost gone. So that is a realistic situation. But unfortunately, Northern Sarawak still maintain the pristine rainforest based on protected area, because most of the rainforests are considered as a national reserve resources. So they are protected by the government. Thank you.
Ok, gracias, doctor. Vamos con la siguiente pregunta. Del doctor Jonathan también dice que si tiene algún programa de monitoreo de las actividades de deforestación como parte del esfuerzo del gobierno de Malasia.
Ese ya se hizo al aire, sería el anterior, Juan.
Sí. Yes, doctor. Sorry, the question was
Okay,
already addressed.
The next question, please. ¿Hay algún impacto de las actividades antropológicas en la contaminación debido a metales pesados aparte de la geología?
The question is there any impact from anthropogenic activities for the contamination of metal despite from the source of geology, from the geological source?
Okay. Yes, there is anthropogenic activities which is common in the lower part of the Baram, so which is lesser compared to Miri River. In the Miri River, the anthropogenic effects are very clear. So particularly downstream is all the elements are enriched about 7 to 15-fold higher than the upstream side. So in the beaches, of course, the sediments are dispersed by the longshore current. So whether it's come from Baram or it's come from Miri Beach, so it depends on the major wind direction, that is northeast to southwest. The entire beach have some anthropogenic effect, particularly the urban source. So in terms of industrial contribution are lesser because there is no much industries in the Baram River. But in Miri River, yes, the contribution from industry as well as contribution from urban areas, particularly stormwater contamination. So which brings a lot of metals, which is mostly associated with the organic matter in Miri River.
Thank you, Dr. Nagarajan. Tenemos la última pregunta de nuestra audiencia. Vamos a ver. The case of the artificial coral system will help the sustainable ecosystems and many countries' coral restoration island regeneration to sampling in the degraded areas What is your opinion?
Doctor, do you want me to repeat the question?
Yep, yes.
Okay. The question is, in the case of artificial coral system, will it help the sustainable ecosystem? In many countries, coral restoration is like regeneration to sampling in degraded areas. What is your opinion?
Sorry, repeat again.
Okay, the question is, in the case of artificial coral system, how far it is efficient for the sustainability of the ecosystem, the present ecosystem? And what is your opinion about the regeneration of this artificial coral system in the degraded areas?
Okay. The artificial coral reefs are the degraded areas. So it is not the major motto of in this region. So the artificial coral reefs are targeted particularly where we have more sand erosion. So in that region, in addition, the abundant oil rigs. So dismantling of oil rigs is a bit costlier. The same time, if we convert those the remaining oil rigs into artificial rigs, which is economically sustainable. But introducing doing in the degraded system, if we do, they may have negative effect rather than positive effect, because there are a lot of factors involved. So each location or each ecosystem may have a unique characters. By studying the unique characters, may be attempted, but it's not always showing the positive result. That's my opinion.
Thank you, doctor. Le damos las gracias a nuestro invitado, a su excelente y estupenda conferencia que nos dio. We thank you guys for your wonderful conference, Dr. Ramasamy. Y bueno, vamos a pasar a la parte de la lectura de la constancia, ¿no? Que le haremos llegar vía correo electrónico. Por favor, Noé, si me haces favor de presentarla. Bueno, la Cátedra Patrimonial en Medio Ambiente, doctor Héctor Mayagoitia Domínguez, en su 6ª edición 2021, certifica al doctor Ramasamy Nagarajan for the keynote lecture on Geochemical Process in River Sediments of Malasia, Climate Change and Contamination. Cátedra Patrimonial y Medio Ambiente, Dr. Héctor Mayagoitia Domínguez, Excellent Professorships and Environment Science, México City, 10 de noviembre de 2021, la técnica al servicio de la patria, la firma del doctor Víctor Florencio Sánchez Hernández, director del CIIEMAD IPN. Les damos las gracias y, por supuesto, les agradecemos mucho a quienes nos siguieron por YouTube. Los invitamos en la siguiente actividad de la Cátedra Patrimonial Héctor Mayagoitia Domínguez con la conferencia High Performance Oxygen Electrolysis Derived from Liver Double Hydroxylase, que será impartida por el doctor Jun Feng, el cual es director del Departamento de Química Aplicada de la Facultad de Ciencias en la Universidad Tecnológica de Beijing, la cual se llevará a cabo el día de mañana, 12 de noviembre, a las 11 a.m., hora del Centro de México, por este mismo canal. No se la pierdan, por favor. Gracias a todo el equipo técnico encargado de la transmisión, a Héctor, Jaime y Noé. Gracias, Shakti, por estar aquí, y cuídense mucho, les agradezco.